This is the sixth part of our Code April series. So we've covered, if you've missed it, we've covered week 1 to week 4 and the first project, the data airline dataset project. In this video, I'll be going through the Titanic dataset, and the link to the notebook I'll be using will be in the description. If you missed the previous video, I'll put in a link up there. Make sure you click on that link to go view the previous project, and I'll have a playlist anyways on the channel, a Code April playlist, where you can go through exercises, solutions for all the exercises and the project. I initially mentioned that it's going to be a 6-part series, but I decided to add 2 more parts. If not, why not, right? So I'll be attempting the project of the Titanic dataset and the airline dataset on Power BI. So we have the Python version, we have the Power BI version, so you can compare and contrast, and I also give my comparison to see which was easier to do and which was better. So expect that later. So after this, expect 2 more videos to talk about Power BI dashboard creation using the data sets. The link I sent across during the challenge was I think was not a the data set there was not really good enough. I attempted my analysis using that. I also put a link in the description box, but I'm not going to do a video to film that. I think for that one, I think there was, so for example, all the females survived and all the male didn't survive, I think. So I feel like it wasn't a good representation of the data. So I'm going to do, so I went to look for a different data, a better data set, so that you are able to analyze and see things. So I still did the analysis using that data set, and I'll put the notebook there, but I won't film that. But it's still the same ideology you'd follow, right? So let's just go on. So if you start by downloading the necessary libraries you use, okay, so this is the link to the data set. You could go read about the data set, and these are just column descriptions. So for example, what sex means and the key. So with sex, you have male and female. So siblings, how many siblings does the passenger have? 0 to, so these are some things you have. Embarked ports, for example, is it from Cherbourg, Queen South, or Southampton? So just things like the class, first class, second class, or third class tickets and categories, things like that. So let's read our data set. So you just read from that. Put the link to where you read the data set. Okay. So I have a 981 data set. So it's smaller than the Titanic data set. So you could do data.shape to see how many rows and how many columns. So we have 931 rows and 10 columns. I have so many. So within the age column, we have 177 data set that were empty. So we think about how to fill those. Then we have embarked, so two rows with we don't know where they embarked from, and I think that's all the missing values we have. So data info, want to see, okay, we have age is a float, siblings integer. What's the PH? Let me see, what's PH? Okay, parent, children on board. Okay, how many parents or children do they have on board if they're alone? Okay, things like that. Okay, so now data.describe. So we say our age. So we have the mean age is about 29 point. That's about 30 years. That's the mean age. The max age we have 80. The mean age we have 0 points. That's month old children. Okay. Then siblings, things like that. Survived. So we have survived 1 and 0. So it just gives you an average of people that survived. We'll do some analysis. So you want to check how many unique items you have. You have zeros and 1. 0 survived and 1 didn't survive. Okay. So now let's categorize the age. So if you've watched the last one, we categorize the age for that one. So in this case, I also want to do the same thing. So if we have missing, like for example, we have missing age, I still want to keep that information. So we'll say unknown. And if you did a child, so if less than 10 is child, between 10 and 18 is between 10 and 18 is a teen, and between 19 and 45 adults and elder, things like that. You can change the number to adjust to see what you want for how you want that to be. So let's just run that age. Okay, so we have our age column. So I want to apply the category, so I want to have my age group. Okay, so I have this age group. So you have adults, so we can do distribution. So we have more adults, and followed by the unknown. Then we have elders, child, and things like that. Okay, so why did I have this? So in some cases, I thought so. So we had that distribution, but I wanted to have a different distribution. So I wanted to add a young adult, and also increase the elder to 56. So things like that. So I just have it. So it's just to repeat that. I want to have good distribution because we have adults. So I just wanted to break that down. And then having 474 adults, I wanted to still break that number down so that we don't have skewed analysis. So I did that again, and you see, let's see. So we have young adult about 272 age. So I think it's better. We have better distribution now. So you could say, so now let's start doing some analysis of survived versus not survival. So let's start doing the analysis of survival versus non-survival. Okay, let's see. Let's replace. We know that, okay, 0 means the person didn't survive and 1 means the person survived. So this is part of the transformation we start doing. So let's see data. So if we do, so you can use 2 ways to do this. Either you do a map or do a replace to give you the same thing anyways. Such that if we do this and do let's just use value counts, so it still gives us the same thing. So you see we have about over 500 people didn't survive and have 300 people, about 300 people survived Titanic. Now let's look at the distribution of the different columns. So this is just the distribution of the numeric column. So you see the distribution. So we have more people within 20 to, let's say, 48. So the majority of our data sets, the age majority of our data set is between 20 to 40. That's for the non-missing values. Then you see the other. So fair. So we have fair, how much they paid. So we have people paying between 0 to less than 200 pounds in this case. So you can also increase. So the same thing we have, you can increase this because it looks squashed. Let's make it bigger. So it's just so you can see the distribution. So about from 18 to about, let's say, 30, 32 or 30 something there about. That's where we have the most of our data concentrated. So yeah, just seeing that in the, so you can also plot the value count bar. So I want to see the bar chart of our distribution. Okay, so you can choose to do the same thing with your bar. I want to see it as pie chart. Okay, so I want to see the same thing. So we have about 61% not survived and 38% survived. Okay, we have our class. Okay, we have more third class as compared to first class and second class within the data. Okay, data survived. Okay. Yeah, so we've done this earlier. So yeah, the same things, just repeating. Okay, so in this case, we can just create a function. So rather than always trying to customize our plot, so I think I can take that out. We'll take this out. So just delete this part. Okay. So so we want to see a survival based on their pie chart. So we have our pie chart figure. We have so different customizing your plot mainly. So we see that we have about 61% of survival and 38% of non-survival, of 61% of non-survival and 38% of survival. So I want to also plot for different columns. Rather than repeating this, I just create a function that plots the pie charts. Okay, and yeah, okay, let's see. Let's do this. So you can plot the survival rates. Okay, I can also choose to plot, let's plot data visualization, survival. So we can plot, so we're focused on survival for now. So let's also do distribution of group by. So I want to see the same thing we did. So you have first class, and so we have this, if you follow the airline data analysis, so we did something similar. So with this, you can also create a function. So I want to see the distribution of, okay, first class. So for the first class, we have more people surviving in first class, even though we are small. Then for second class, we have more non-survival, but the difference is not so much. But third class, we have lots of non-survival. So from this, we're already saying that, for example, if you want to go, if people on Titanic, if you're on the third class cabin, if you're on the third class cabin, you have less chance of survival. But if you're on the first class, you have a greater chance of survival. Okay, so I think this is the same plot. Okay, third class, and the same plot. So in this case, we use the matplotlib. You could also plot the same thing using Cpon. So yeah, it's easier to plot. So the same thing, so I just created a function so that you don't always have to use this whenever you want to plot. So you could just say plot group charts. In this plot group group bar chart. So just repeating the same chart based on survival. So I wanted to see also sex based on survival. So we have more female surviving and more male not surviving. So yeah, so the essence of using functions, so I don't always have to call. So I want to see based on where they're embarking from. So you have more people embarking from Southampton, not surviving, and you have people embarking from the sea, survival. So things like that. So the parents thing. So I think it's parents. So let's go back to column description. So the PH was the parents and okay, people or parents or children on board. So people with none on board is generally shows that had general low survival, and people with that just gives you different things. So also see people alone and people that's if they survived or not. So alone first. So if you're alone, you have higher chances of survival. Alone true. Whereas if you're alone, you have less chance of survival, things like that. Okay, so you can, so the same thing, you have your group bar, you could also have it as stack. So this is me just showing different visualization to show the same results. So if you want to see the same, so in this case, so it's the same function I had initially, but I just only added a new argument called stacks. So if you want to stack, so you can, if you want to stack, if the default is false, but if you want to stack it, just make it true and you have your stack so if I run this, and I have this, so you have our stack true, so you can choose to have it as stacked or not, depends on what you have. So for example, we have this survives or no. I could also have the same thing. So let's see, let's plot the same thing. Let's see, stacked, so is that to stack true? So let's see, to stack true. Let's see, so we just stack, so it's the same thing you have, but you just have it as stacked. So for example, we have more child surviving and women surviving. If you're a man and you're on this Titanic, you have less chance of survival. Okay, that's what our data set is saying. I didn't see that. Okay, so let's do the distribution. So remember we have our function plot pi. So I wanted to see the age group to see what's the difference. So we have our young adult as more. We have our adults followed by adults. We also have a percentage that we don't know or their age. Normally people want to fill the missing value with mean or median, blah blah blah. I just rather not do that. So it depends on, you have to understand your data and what you're trying to achieve. So you have to understand your data and what you're trying to achieve. Okay, so let's do the distribution. So we've done pie chart before, the histogram before, but you can increase or reduce the bin to see how things are different. So I can do plt.grid. I want to show grid. Okay, so I want to show the grid to see how they differ. So you can choose to increase your bin size. You can choose to increase or reduce bin size depending on what you want and how you want to see how they are distributed. So generally you have higher percentage of higher number of people within 20 and 30 years. So it's just seeing your group chat. So this again plotting my group bar based on female and male to see. For female, also generally for the male, we have more adults followed by young adults. So I think it just shows the same distribution mainly. Then sex, so let's see sex, we have more male than female. Pie chart, let's plot group chart. So different variables or different column attributes with the sex column. So let's see, so generally we have more male across all adult, child, and things like that. I think the same thing we had in the previous one, but I think this chart shows it better. Let's see the sex based on people with no siblings. So you have more males. Generally, the males are generally, so we don't really see much difference there. So let's look at the sex based on their classes. So we have so again we have generally more male in the data set. So this doesn't count for anything. But survived based on, so we have more males, so more male died, as compared to female. So the percentage of survival is smaller with male. So let's look at the fair distribution. So we have more distribution. So let's plot this. Okay, we have people paid between 0 to 100. I think these are more like the third class. So let's just include grade, PLT or grade. So just show the grade in the data set. So you can choose to, let's increase this bin to, let's say 40. So let's just break down. Okay, still nothing much distribution. So let's also look at, so to show distribution, there are different charts to show distribution. So let's look at the box plot. So in this box plot, I want to see distribution of survival versus age to see. Okay, so we have non-survival between 0 to about, I think it's just focus. So they have approximately the same mean. Okay, nothing much to show there. So you can really zoom in. So to use your lim, so lim, plt.ylim. So in this case, we have it from 0 to 80. So if you want to crop this based on this, you can use plt.ylim to reduce your y limits. So in this case, I'm also looking at survival versus fair. So generally, we have people that survived, they paid up to like when we did initially. So first class had higher survival. So you see like people over 500, like about 500 that paid 500 survived. But with this, you have at least people that survived. The maximum they paid was about 200 and something. So you can see that distribution. So if you're doing outlier analysis, this might be considered outlier. This can be considered outlier, just depending on what you want to do. Oh, the same thing. Okay, I think this is the same. What's the difference? So you can change the palette. For example, this is just blue. You can adjust that to change the palette to have different palettes. You could just go browse palette and know the palette you want to use. So in this case, I wanted to see survival versus fair. Okay, yes, the same thing, but using a wide limit, so just up to 5 to 100,000, £100 to see what the difference is. So you can see you have more people surviving, and that paid within 200 to 20 to 60 pounds approximately, with the mean around 20 something pounds. That's how you start interpreting your box plot. So you could also do the same thing for, so based on the fare, also for first class, second class tickets. So you see that the first class definitely generally have more fare compared to second class and third class. Okay, so the same, still analyzing the fare with class. If you use your Y limit to just 100, you see that you have more people within the first class one. With this, you can generally see that the first class range would be, let's say, from about £40 to more. So, but you see some people having, for first class, having less paying less. That could be as a result of early ticket. So these are some things you can start looking at. But generally, the third class is about, let's say, 10 to 15 pounds or 10 to 18 pounds, and you have some second class from 18 to approximately about 20 something, 30 pounds. They're about to, why you have some kind of, for example, you have an overlap between the second and the third could be as a result of early bird and late ticket buying, things like that. So that's some things you start looking at. Okay, so what else? Class and age. You want to see the age. So people within the third class are usually younger. So people with first class that paid first class generally are older than people with second class and third class. So you can see here, so for example, you want to start marketing. If you work with Titanic data, Titanic, for example, you want to see, okay, people you want to focus you can now start doing your targeted ads. So so this is how you can start using this data. So you already have your demographic. You want to see people that take certain tickets. So if you want to do adverts, these are some areas you can now start focusing on. So another way to show distributions are violin plots. So they are similar to box plot and are interpreted similar to box plot. So you know that we have been using the Seaborn library for our box plot, our distribution for box plot and violin plot. So it just shows you the same thing. I'm not going to go through them. So you see where you have like the biggest bubble size, where you have more data concentrated. So, but at least it shows you the same thing your box plus will show you, but it just depends on what you prefer and what answers your question. So you could have them side by side to see the difference. Okay, what else do we have to say? Yeah, so those are just the different plots. So you could also plot some scattered plots. So yeah, in this case, the scattered plot would mainly be by using numeric columns. So we don't really have a lot of numeric. So we have age and fair. So you want to see the distribution with here. There's no really trend or pattern between the age and the fair. So in this case, I use yeah. So survived by, so the color. So you can't really identify any specific pattern. Another one thing we can also do is to do a correlation matrix to see how things are correlated, how the different columns are correlated. Okay, so in this case, we just picked out all the numeric. So you want to do your correlation matrix, you want to use your numeric column. Okay, so okay. So in this case, because I wanted to also see survival, so I had to convert my survival to integer. Okay, so I had to convert my survival to integer. So the same thing, just have it as integer. So it depends on what. So if let's say let's run this back, and so this just shows you correlation between survival and age. So you have a negative, very weak negative correlation. So there's no, we can see other than having doing those columns individually, you could just run something like using your heat map or plotting your correlation matrix on this. So this is our correlation matrix, but it doesn't really say anything because there are lots of numbers. So you can use a heat map to show that correlation. So where you have a very strong light color, you see that there's strong correlation, and when you have very dark color, you have negative correlation. So let's look for the items with the highest correlations. Yeah, I think it's the fair and parents or children on board. I think that's it. But generally, we have general. So we have this one: the survival versus survival versus the fair. So if you pay more, there's like that's people within the first class. They are more likely to survive. Okay, so that just gives you a general correlation of your data set. Then so you can just summarize your data based on your findings. Definitely, we have more female surviving than male, and we have more people in first class cabin surviving than people in the second or third class. So by this, for example, if you have a female that is on board on the first class, you have a very high chance of survival. I hope this was interesting and this was insightful and wasn't so difficult. Again, if you participated in the challenge and you chose this project, how did you find my own analysis and how different was it from yours? Did you find it difficult? And don't forget the link to this notebook will be available in the comment section or in the description. So just look for it and you can easily download my notebook.